Hello, this presentation is on the chain rule. The chain rule is a formula used to find the derivative of a composite function. Now, let's go back to the uh, derivative functions that don't require chain rule. For example, if we were to take the derivative of sine of x, well, that's cosine of x. If we were to find the derivative of x squared minus 4, well, that's 2x. So derivative of x squared is simply 2x. Derivative of negative 4 is 0. So that can be done straightforward. Now, when it comes to a composite function, for example, the function sine of x squared minus 4 is a composite of two functions, the sine function and x squared minus 4. Because what we can do actually to show that, we can say, well, let f of x be sine of x, and let g of x be x squared minus 4. So if we take, when we take the composition of f of g of x, so when we do um, f of g of x, which can be written as f of g of x like this, and we know that g of x is x squared minus 4, and f of x squared minus 4 is found by substituting x squared minus 4 for x in the function f. So it will be sine of x squared minus 4. So we were able to actually decompose 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 the function sine of x squared minus 4 to two functions, and then take the composition of these two functions to go back to sine of x squared minus 4. So now, how do we take the derivative of a composite function such as sine of x squared minus 4? Well, here's the idea. So when we take the derivative of sine of x squared minus 4 um, with respect to x. So um, I can find the derivative by using the chain rule as follows. So first I'm going to say, well, derivative of sine of x squared minus 4 with respect to x squared minus 4. So what does this mean? If we go back to this function here. So what this is saying, it is saying that I want the derivative of the sine of x squared minus 4 when a change takes place in x. So when x changes, so sine of x squared minus 4 changes, but actually there are two steps. When x changes, the x squared minus 4 changes. Whenever x changes, x squared minus 4 changes. And then the sign of that x squared minus 4 will also change. So we have a change that takes place with respect to x, and another change that takes place with respect to x squared minus 4. So therefore, I'm going to decompose this to two derivatives. The first one, I'm going to say, okay, I'm going to find the change in sine of x squared minus 4 when x squared minus 4 changes. But the the change in x squared minus 4 takes place only when a change in x takes place. So with this, I would be able to find the derivative of this composite function. So because really the first change is when x changes, and then the second change is when x squared minus 4 changes, and the third one is the sine. So it means, I'm going to repeat myself here, derivative of sine of x squared minus 4 with respect to x squared minus 4. It means when x squared minus 4 changes. And the x squared minus 4 changes when x changes. And if you look at it in kind of a simple algebraic kind of algebraic, like if you look at it um, in terms of simple algebra, which can't be done exactly here, but it helps us understand this concept. As you see, if we take this as a product of two fractions, then this cancels with this. So we're back to what? The derivative of sine of x squared minus 4 with respect to x. And that's what actually we want to find. But we don't want to do this. We just want to take two derivatives. First one is with respect to x squared minus 4. Second one is with respect to x. And that will give us the derivative of sine of x squared minus 4 with respect to x. Right, let me fix problem here. So x squared for the x, and here missing the parenthesis. Okay, so now let's finish this example. So what is the derivative of sine of x squared minus 4 with respect to x squared minus 4? Well, if I ask this question differently, if I say, what is the derivative of sine, let me write it down over here. What is the derivative of sine of u with respect to u? That this simply would be cosine of u. How about if I say, well, I have used u to um, to mask the x squared minus 4. So the u is x squared minus 4. So when I take the derivative of sine of u with respect to u will be cosine of u. Well, it's the same as saying derivative of sine of x squared minus 4 with respect to x squared minus 4. It's the same idea. So this will be cosine of x squared minus 4. And what is the derivative of x squared minus 4 with respect to x? Well, that's simply 2x because the derivative of x squared is 2x. Derivative of negative 4 is 0. So finally, I'm going to say, well, it's 2x. This is just rearranging this expression. So 2x times cosine of x squared minus 4. So this notation I've been using here to explain how the chain rule works is called the Leibniz notation. But there is an easier way how to find the derivative of a composite function, which is called the inside-outside rule. Inside-outside rule. So how does the inside-outside rule works? Well, if I go back to this example, let me write it down over here. So I'm going to say, well, I want to find a derivative of sine of x squared minus 4 derivative. So the inside function would be x squared minus 4. It means first I'm going to take the derivative of x squared minus 4, which is 2x. And the outside function would be the sine of x squared minus 4. But I take the derivative of x squared minus 4 with respect to x. And then when I take the derivative of sine, it will be with respect to x squared minus 4. It means I'm going to treat x squared minus 4 as if I'm taking the derivative of simply sine of x with respect to x. So, and that's cosine of x squared minus 4. And this is actually, it's called the inside-outside rule, which is simpler. So, here's the chain rule formula. So using the inside-outside rule. So if we take the derivative of f of g of x, which is the composition of f and g functions. That's this. So what I do, the inside-outside rule. So I take the derivative of g of x, which is the inside function, and then the derivative of the outside function, which is f, keeping g of x as is, no change. So here are the steps. Differentiate the inside function g of x, that is g prime of x. Then differentiate the outside function f with g of x left alone. We just copy and paste the g of x. That's what it means. So, and then we multiply the derivative of g prime of x by the derivative of f prime of g of x. And that's exactly what we did over here. Um, go back up there. So what we did, we found the derivative of x squared minus 4, which is 2x, and then the derivative of the sine, which is a cosine, and then they are multiplied. It's 2x times the cosine of x squared minus 4. All right, let's work on the on example one. Example one says use the chain rule to find dy dx. So we're going to use the inside outside rule. So here the inside function is 3x plus 1. The outside function is the square of that. So how does it work? When you take the derivative of 3x plus 1, that's simply 3. And when you take the derivative of 3x plus 1 squared, what I mean here, taking consideration only that square. Well, if we think of 3x plus 1 as simply x, so let's say it's x squared. So what is the derivative of x squared? Well, that's 2x. So it means 2, but it's not x, it's 3x plus 1. Because we're just making an assumption. Let's say 3x plus 1 is simply x. Then the derivative of x squared becomes 2x. So first you take the derivative of the inner function, which is derivative of 3x plus 1, which is simply 3, and then the outer, which is the that expression squared. So the square is the thing that matters here. So you apply the power rule, which is 2 times 3x plus 1 to the power of 2 minus 1, which is 1. And then we simplify. 3 times 2 is 6. 6 times 3x plus 1. We can keep it like this, so we can distribute the 6, so it becomes 18x plus 6. Go to the example B. So let's determine which one is the inner, which one is the outer. So the inner function is, or the inside function is 2x, and the outer function is the sine of that 2x. Notice here, it's not sine times 2x, it's sine of 2x. So when you take derivative of 2x, that's simply 2, and then the derivative of sine, that's cosine, and as we said, we just carry the inner function or the inside function, which is 2x, and that's the derivative. This is in simplest form. Okay, next example. Inner function is x squared minus 4. The outer function is sine again. So, that's the same example that we already went over. So, it's 2x cosine of x squared minus 4. All right, let's do example D. So the inner function is x minus 1. And the outer function is the radical of that. Okay. So when you take the derivative of x minus 1, that's simply 1. Now, what's the derivative of the square root? Let's review the derivative of square root of x. Let's go back to review the basic square root, the basic square root of x derivative. So derivative of square root of x is actually, first you write square root of x as x to the 1/2, and then you take the derivative using the power rule. So using the power rule, the 1/2 becomes the coefficient, and then you take a 1 away from 1/2. So that's 1/2 times x to the negative 1/2. And then, of course, what you do 1 over, move the x to the negative 1/2 to the bottom. That becomes x to the 1/2. And then you can write this you write x to the 1/2 as square root of x. So it will be 2 times square root of x. So what I want you to catch here is there's a shortcut that we're going to be using. Each time we have a square root, we don't want to go through all these steps. So this is derivative of square root of x. So what you want to do, you want to take the derivative of the radicand, which is the expression inside the radical, which is in this case x. And the derivative in this case of x is simply 1, divided by 2 times the square root of that expression. So I'm going to repeat. The shortcut is taking the derivative of the radicand divided by 2 times the the square root of that expression. In other words, 2 times the function itself. So that's the shortcut we're going to take. So to finish our example, first we said we take the derivative of the radicand, in this case is 1, divided by, let me change something here. So, okay, I'm going to repeat, derivative of, or let me write it down. So derivative of x minus 1 divided by 2 times the square root of x minus 1. So I'm taking the shortcut here, okay? At the same time as it is a chain rule. So derivative of x minus 1 is simply 1, and then 2 times the square root of x minus 1, and that's my derivative. So this is how we're going to, each time, take the derivative of the square root. This is how we're going to do it. All right, let's do example E. Example E, what do we have? We have the inner function, which is 3x. We have the outer function, which is cosine. So we start with the derivative of 3x, which is simply 3. And then the derivative of cosine actually is negative sine of 3x. And then you just multiply the 3 by the negative, so it becomes negative 3 sine of 3x. Example F, the inner function is x squared plus x, and the outer function is sine. So the derivative of x squared plus x is 2x plus 1, and the derivative of sine is cosine. Okay. All right, next, it will be repeated use of chain rule. What this means, it means we may have to use a chain rule more than once. Use a chain rule and then you use it again. That happens when we have a composition of more than 2 functions. Let's say a composition of 3 functions. For instance, let me show you over here. You can easily see it. So there is a 5x composed with tangent. So you can say, okay, f equals tangent of x, and g equals 5x. So f of g of x will be tangent of 5x. But that's not the only thing. We also have the third one, which is the radical. So you can do actually the composition of 3 functions. So now this is composition of 3 functions. Then the derivative most likely is going to be three derivatives multiplied. I mean, there will be multiplication of 3 derivatives. Multiplication of 3 derivatives. So let's see how this works. So the most inner or inside function will be 5x. So derivative of 5x is 5. We're done with that. Second one is derivative of tangent. What is derivative of tangent? Derivative of tangent is secant squared. Of course, you need to carry the 5x. And then what's the derivative of radical? It's 1 over 2 times the radical of tangent of 5x. So this is the same actually as saying taking the derivative of tangent of 5x, which is 5 times secant squared 5x, divided by 2 times the square root of 5x. It's exactly the same idea. So 5 secant squared of 5x divided by 2 times square root of tangent of 5x. And that's the final answer for this example. Now let me take you back to example A. It's weird that I started with example B, but example B is more straightforward when it comes to seeing the composition of 3 functions. Example A, it is, but a bit not so obvious because of the 5 minus. So let's work on this one. So the first inner function in here, or the most inner one, is 2t. Then the 5 minus sine 2t, that's the next one. Let me change something. Take this out. Okay, good. So 5 minus sine of 2t. So 5 minus sine, you can look at it this way. And then the last one is a tangent. So let's start with 2t, which is 2. Derivative of 2t is 2. What's the derivative of 5 minus sine of 2t? Well, derivative of 5 is 0. Derivative of sine is cosine. And what's the derivative of tangent? Secant squared. Secant squared of what? Of 5 minus sine of 2t. Let's, separate. Let's just separate these two. Can we simplify here? Yeah, a little bit, just a little bit. The 0 minus cosine of 2t is simply negative cosine 2t times 2, so negative 2 cosine of 2t times secant squared of 5 minus sine of 2t. And that's the derivative of this function. Let's do another one. So what do we see in example C? Let's break it down. 2x would be the most inner one, or the most inside function. And then the 1 plus cosine, and then the square. Okay, so derivative of 2x is 2. Derivative of course 1 is 0. Derivative of cosine is negative. Let me remove the plus. Derivative of cosine is negative sine of 2x. Derivative of cosine is negative sine of 2x. And then the derivative of the exponent will be 2 times 1 plus cosine of 2x. Okay. Now 0 minus sine of 2x would simply be negative 2 sine 2x, because we're multiplying that by 2. And then this multiplied by 2 plus 2 cosine 2x. We can keep this like this, or we can just, okay, let's do something else. Let's move this. I would rather multiply the 2, this 2, by the negative by this 2. So it becomes negative 4 sine 2x times 1 plus cosine of 2x. That's a better way. Okay, why don't we keep it like this? We could distribute, but we don't need to. All right, let's go to example D. The first inner function is 2x minus 5. No, let me, no, there is a problem here. So we have to be careful in here. So y equals x cubed times 2x minus 5 to the fourth. So first of all, the x cubed and the 2x minus 5 to the power 4, these are two separate functions and they are multiplied. So we have a product. We have a product of x cubed and 2x minus 5 to the fourth. Well, we need to use the product rule first. So first I'm going to say y prime equals the derivative of x cubed times 2x minus 5 to the fourth plus derivative of 2x minus 5 to the fourth times x cubed. So derivative of x cubed times 2x minus 5, so that's 3x. Derivative of x cubed is 3x squared times 2x minus 5 to the fourth plus. Now, derivative of 2x minus 5 to the fourth, well, we need to use a chain rule. The inner function is the 2x minus 5. The outer one is the power fourth. So the derivative of 2x minus 5 is 2, and then the 4 you just use the power rule. So 4 times 2x minus 5 to the third, and then times x cubed. Okay, so in this case, we may have to simplify, and definitely we don't want to FOIL the 2x minus 5 to the fourth or the 2x minus 5 to the third, because that's going to be just extremely time consuming, and there's no point of doing that. But we can actually simplify by factoring. So notice that x squared, x cubed, the common factor between x squared and x cubed is x squared. And the common factor between 2x minus 5 to the fourth and 2x minus 5 to the third is 2x minus 5 to the third. So we're going to take x squared as a common factor and 2x minus 5 to the third as a common factor. Oh, I said x squared, sorry, x squared. So that should be x squared, not x cubed. So x squared, between x squared and x cubed is x squared, and between 2x minus 5 to the fourth and 2x minus 5 to the third is 2x minus 5 to the third. Now, what's left? We got 3 times 2x minus 5 plus 2 times 4 is 8, and we already have the 2x minus 5 cubed, and all we need to add is x, because x squared times x is x cubed, and we already have 2x minus 5 cubed over here. It's already factored, and the 2 times 4 is 8. So now this is x squared times 2x minus 5 cubed, and we can simplify this. If you distribute the 3, you got 3 times 2x, that's 6x, plus 8x, that's 14x, and minus 3 times negative 5, that's negative 15. And that's, this is in simplest form. Of course, we're not going to FOIL 2x minus 5 cubed and so on. We're not going to do that. Example E. Example E, first we have a quotient rule, because x is divided by the square root of 1 plus 2x. And then we'll see which part of the quotient rule needs chain rule. So let's start by simply taking the derivative using the quotient rule. So we write y prime equals the derivative of x times the square root of 1 plus 2x minus derivative of 1 plus 2x times x, all divided by 1 plus 2x square root squared. Okay, good. Now, derivative of x is 1, so there is no need to write a 1, times the square root of 1 plus 2x. Now, derivative of square root of 1 plus 2x, well, you need a chain rule here, but we're just going to use a shortcut. We're going to just use a shortcut, which is chain rule. But whenever you have the square root of some expression, let's just take the derivative of that expression, which is in this case, derivative of 1 plus 2x is 2, divided by 2 times the square root of that expression. So that's done, times x. Don't forget to multiply by x. Oh, no. Okay. Times x. Okay, good. And let's not forget dividing by the square root of 1 plus 2x squared, which is simply 1 plus 2x. because we're squaring square root will be just the square, the radical will no longer be there. Okay, now let's keep in mind that the 2 crosses out with the 2. So we need a common denominator over here. So the common denominator between these two fractions is square root of 1 plus 2x. So that means we need to multiply. Let me just move this a bit far away. Let me put the equal sign there. I'm going to use different color. So we need to multiply the square root of 1 plus 2x by square root of 1 plus 2x. And of course, divide by square root of 1 plus 2x. So now it looks like we have the same denominator. So we can go ahead and add. Square root of 1 plus 2x times square root of 1 plus 2x is simply 1 plus 2x. Minus 1 times x, because these two crossed out with these two. So what's left on top is 1 times x. So minus x. All divided by square root of 1 plus 2x. And this entire function is divided by 1 plus 2x. Now what we're going to do, we'll multiply by, simplify and multiply by reciprocal. So if we take a look here, 1 plus 2x minus x, well, that's 1 plus x. Divided by square root of 1 plus 2x times the reciprocal of 1 plus 2x, which is 1 over 1 plus 2x. Okay, now 1 plus x times 1, well, that's 1 plus x. How about square root of 1 plus 2x times 1 plus 2x? Well, we have two different choices. We can combine these two under one radical, or under one exponent. It means using put it in exponential form. So if we do that, either way the answer will be the same, just the format will be different. If we use let's go with the exponent. Let's do both. So if we write the square root of 1 plus 2x as 1 plus 2x to the 1 half. So 1 plus 2x to the 1 half. And then times the 1 plus 2x. So on top I have 1 plus x. On the bottom I have 1 plus 2x to the 1 half times 1 plus 2x to the 1. So you add the exponents. So that becomes 1 plus 2x. 1 half plus 1, that's 3 halves. So one option would be 1 plus x over 1 plus 2x to the 3 halves. The other option, I'm going to write it down over here. It would be 1 plus x divided by the square root of 1 plus 2x cubed. And that would be, it would be this or this one. Really, if the question was a multiple choice question, then then whichever is available. If it's not a multiple choice, then it really doesn't matter. You leave it in this form, in that form. Both answers are acceptable and correct. Okay, let's do an example. Example F. Example F. So example F, we don't have a product here. We gotta be careful. This is sine of cosine of t squared plus 1. This is not a sine times cosine. So it's not, and there's no product rule in here. So here's the first inner function. Second one is a cosine. Third one is a sine. So this is one of the more straightforward. So what's the derivative of t squared plus 1? Well, that's 2t. What's the derivative of cosine? That's negative sine. What's the derivative of sine? That's cosine. Okay. So this is the only thing we can do is multiply the 2t by negative. So negative 2t, let me write a t a bit better because this looks like almost a plus. So 2t, 2t, sine of t squared plus 1 cosine of t squared plus 1. And we keep it like this. In regards to techniques of chaining, we pretty much went over several examples. So follow the same idea, use the same idea, same checks, and you can get by any composite function. So application examples. This is something we've seen before. So find the slope of the line tangent to the curve. So find the slope of the line tangent to the curve y equals sine to the fifth of x at the point where x equals pi over 3. So pretty much, since we're looking for the slope of the tangent of the line to the curve at one point at x equals pi over 3, so we need the slope at an instant. And in this case, we just use the derivative to find the slope. So we start by finding the derivative, which is the slope m that we're going to use to write the tangent line will be the derivative of the function y at x equals pi over 3. Okay, so this is just a notation. This vertical line, it means at and then x equals pi over 3. So the derivative of sine to the fifth of x at x equals pi over 3. So the way here the function is written, sine to the fifth of x, it may not be obvious which one is the inner, which one is the outer. So I'm going to do one more step, which I'm going to write the function as sine of x to the fifth, and then take the derivative at x equals pi over 3. So now it's obvious which one is the inner, which one is the outer. So the inner is sine of x, and the outer is the power fifth, the fifth power. Okay, now we can first take the derivative of sine, which is cosine, and then the fifth will be just the power rule, will be 5 times sine of x to the fourth. And this is good at pi over 3. That's what the question wants. So we got 5 cosine pi over 3 times sine of pi over 3 to the fourth. Now, what is cosine of pi over 3? Going back to the unit circle, cosine of pi over 3 is 1/2. And sine of pi over 3 is root 3 over 2 to the fourth. Now we need to simplify 5 over 2. Root 3 to the fourth, well, that's root 3, that's 9. Because you got root 3 times root 3, which is 3, and then another root 3 times root 3, which is 3. 3 times 3 is 9. And then 2 to the fourth is 16. So 9 times 5 is 45. And 2 times 16 is 32. And that's, you keep it as 45 over 32. There is no common factor between the two, so we leave it as is. Example B, oh, did we answer? Yeah. Yeah, okay, so before we go example B, so this is the slope of the line tangent to the curve, y equals sine to the fifth of x at the point where x equals pi over 3. Let's go to example B. Show that the slope of every line tangent to the curve, show that the slope of every line tangent to the curve y equals 1 over 1 minus 2x cubed is positive. So pretty much when the question says show that the slope is always positive, it says the slope of the tangent line, of course, which means we just take the derivative. And then once we take the derivative, we want to make sure that that derivative will always be positive. So, all right, let's start. So we take the derivative y prime of, so y prime equals the derivative of 1 over 1 minus 2x cubed derivative. So I'm going to avoid using the quotient rule here. What I'm going to do instead, I'm going to move the 1 minus 2x to the third to the top, so it becomes to negative 3, and then take derivative. So now the inner function will be 1 minus 2x. The outer function would be that exponent negative 3. So the derivative of 1 minus 2x is negative 2. And the derivative of the outer function just uses the power rule, so negative 3 times 1 minus 2x to the negative 4, because it's subtracting 1 from negative 3. And then let's simplify. We got negative 2 times negative 3, that's 6. And move 1 minus 2x to the negative 4 to the bottom. So it becomes 1 minus 2x. I said to the negative 4, I'm sorry. You move the 1 minus 2x to the negative 4 to the bottom, which becomes 1 minus 2x to the 4. Now, what we notice in this derivative, we notice that 6 is a positive number. So 6 is greater than 0. Also, the 1 minus 2x to the fourth, well, anything to an even power is always positive. So we're also going to say, well, 1 minus 2x to the fourth is greater than 0. We don't want it to be 0 because this is in the denominator. So let's not, so we need to write greater than 0, not greater than or equal 0. Okay, because the domain of this function excludes any x that makes the denominator equal to 0. So we don't have to worry about the 0 here. So any value other than the x value that makes the denominator equal 0, this denominator will be positive. So 6 is positive, 1 minus 2x to the fourth is positive, and a positive divided by positive obviously is positive. So we have actually concluded that, okay, the slope of every tangent line to the curve is positive. Okay. Example C. Example C. Example C says find the value of f of g, or the composition of the function f and g at the given value of x. What is the given value of x? That's negative 1. What is the function f? What is given as in terms of u? So f of u equals 1 minus 1 over u. And u is g of x, which is 1 over 1 minus x. So to work on this without doing a lot of work, actually, I'm going to take the composition f of g of x first, which is f of g of x. What is g of x? G of x is 1 over 1 minus x. Then you substitute 1 over 1 minus x for u in the function f, which is 1 minus 1 over, and then we substitute 1 over 1 minus x for u, so 1 over 1 minus x. And then this is 1 minus, if you multiply 1 by the reciprocal of 1 minus x, it will be 1 minus x. Simply 1 minus x. Okay. So 1 minus 1 plus x. Oh, no, sorry. Okay. So it's 1 minus, oh no. 1 minus 1 plus x, which is what? Which is x. So what's the derivative of x? So we go back and write, okay, um, so this will be simply derivative of x, which is 1. So this is the end of the presentation. Thank you for watching.